Hey folks, Larry from leamyelectric. A few months ago I did a video on a wind turbine control system that I built, and this is actually what came out of it. After all the R&D we did, testing, we finally came up with a model that works really great. This is basically for the Chinese grid-tied inverters, and I want to walk you through here and show you what it does and all the stuff I've included in it. This box is being shipped out tomorrow to a customer in Western Pennsylvania. This is the third one going out, so I thank the customers out there for believing in my product. But what I wanted to show you is what I've discovered over having wind turbines and using these grid-tied inverters and how to get the most power out of things. And there is a lot of redundancy in this system, based on a real grid-tied inverter. Now, we know that the Chinese grid-tied inverters are non-UL approved, but what are you going to do? I tried to get it as close as I could to using these things with meters and just to make it more safe, more compact, and more efficient. So what we have here is this is a dual system, by the way. That's why there's two meters. The meters illustrate DC power for each turbine. So this box is basically built for two turbines. We can make them for one. We can make them for probably, I'd say no more than three with this size box. This is basically a 16 by 16 box, okay? And if you notice, there's also a wind meter on here. I just have it attached to the board up here for illustrations, but it does come with a wind meter. It's the in-speed wind meter. You can look it up online. It's a great little meter. So what we have here is we have a DC meter, all right? And this DC meter will show on the bottom, it has P for power. And you can see the legend over here. All right, and you push the button here, it'll go amps, it'll go cumulative amp hours, volts, and it shows two different displays. You can do the same thing up here. So if you want your power at the top and your volts at the bottom, you can do that, or vice versa. Okay? And this thing is really quick. And when I mean quick, I mean it's like, I think it's 5 readings per second or something like that. It's crazy. So it gives you very accurate readings. There's no lag time in them at all. Over here you have the in-speed meter. And, we can simply spin this guy up here and you can see some wind speeds. Just spin it. All right, see it spin it up there. All right, and what this is going to do is not only going to tell you your wind speeds, but this thing is going to switch inverters. And what I mean by that, it's going to take, let's say you have a 500 watt turbine or a 1,000 watt turbine. And in low winds, we know that the 22 to 60 volt inverters take about 10 mile an hour winds before you get 22, 24 volts to make them work. However, in the smaller wind speeds, 5, 6, 7, 8, 9 miles an hour, since you're not getting any power out of them, you can use a smaller inverter, meaning a 10 to 30, like a 250 model. So what this will do is it'll switch from the 250 to the 22 to 60 in higher winds. So your turbine will be running at a higher RPM, lower amps, and more efficient. It'll be running at a higher voltage, lower amperage, meaning things won't heat up. And the voltage is easy to create, as you know, with the turbine. It's the amps that's hard. You got long runs and all that stuff. So I want to show you the insides as well as the outsides, and I'll show you how this thing ticks. So you've seen the meters. We have the DC meter. We have the in-speed wind meter, and that'll show you maximum wind speed. It'll show you calories. There's all kinds of stuff on here. It'll show you average wind speed. I usually keep it on max, and then if you just push this in and hold it, it'll reset to 0 again, okay? So pretty nice. It doesn't have a light on it. However, it's still a very nice unit. Now over here, what we have, sorry about that. Over here on this side, we have 2 DC switches. These are 60 amp DC breakers. They're not AC breakers, they're DC breakers. All right, and they're up here. Okay, so that shuts off your DC power coming from your turbine. They're 60 amp, and the reason they're 60 amp is because you'll be running at a higher voltage anyway. So your amps might only be 20 amps. Now, I oversized the breaker because obviously we don't want the things tripping all the time and shutting off your DC power. So it's basically a redundancy on the DC side. And it just shuts the DC power off from the turbine. It does not shut off any other DC. All right. Down here we have a plug. It's an AC plug, and that is for your in-speed transformer that comes with the kit that's incorporated in this system. All right, because the in-speed system needs 12 volts for it to function right. And I'll get into that when we open up the box. And then over here you have your normal kilowatt meter. which the inverter is plugged into, and I have an inverter set up with a WindBlue 540 PMA for demonstration, which doesn't work very well with the system, guys, I'll tell you that. Maybe a different car type PMA or PMG will work. I know Thermodyne out there is coming up with some really good ideas. Maybe check their PMA out in the system. I've only tested the system with WinMax or HY Energy system, and they work fantastic with it. So I'll get into running this in a little bit. Over here we have a 15 amp AC fuse, and down here we have the AC switch. All right, and this switch will simply shut off your AC power. So you can see the inverter is on right now. We shut off the AC power, and it'll shut off the kilowatt meter as well. Now the inverter is back on. Excuse me. Okay, so that's pretty much the outside of the system. Over here, I did incorporate two nice holes. One's a 3/4 inch Romex connector, and one's a 1/2 inch. So you can run your wires in there. And you can always drill this box out and make more holes if you want. I don't know where you want the holes, so excuse me. I put them where I think they should be, and if you want to put some on the bottom like that, that's fine. I don't think this board's going to need a fan or anything like that because, again, it's for grid tie. And you're going to be running at a higher voltage and lower amperage, so you're not really going to be pushing a lot of heat. However, if you want to add a 12-volt fan, that's fine. So let me open the board up here. Now, when I open this up, the connectors on these meters are probably going to pop off, and that's fine because the door basically, because they're only that long, I can't get the door to way open, so we just kind of pop them off here, and they'll pop off. Grab them in here, take them off the board. All right, now we can get the door open. Now, this is where the business is. Over here, and it's the same thing. This is just set up for 2 turbines. So we'll go into the AC part first. Down here is your L1 and your neutral. That's coming from your panel, your circuit breaker, dedicated line to the system. All right, and then to the left of that, which is right here and here, here and here, this is your positive and your negative for your DC power. Now what I did was I put a transformer in here. Takes AC and converts it down to 12-volt DC. What's good about this system is, and what you should do, is run this off a battery bank. Because if you have a constant 12-volt DC, when the grid goes down, your meters will still stay on. All right, and that's something you probably want. However, if the grid does go down and you have the correct dump load on here, this will protect the turbine. So if this inverter's off, it goes to dump load and loads the turbine down. When the power comes back on, it will release the dump load and the system will be up online again. I have my system tied to a 12-volt battery bank. However, you can just use a transformer in here. I do not supply the transformer for this. So you either have to get a transformer or you supply a 12-volt battery bank. Again, a constant 12-volt DC source is needed for this. Okay, because these relays work off DC. All right, so that's your input and also your ground. Your ground's down there. You have a couple lugs down there to hook your ground up to, and the board's grounded too. It's grounded over there. All right, you have bus bars in here for your inverters. Bus bars over there. You have an 80 amp rectifier. All right, and obviously your wires from your turbine are right here. That's all you got to connect up. It's all pre-wired. Basically, you're just connecting up the 120, the 12 volt, and your PMA. Everything else is done for you already. It's already pre-wired. It even comes with the kilowatt meter. All right, so that's that. Now, let's talk about the wiring in here. Well, the wiring in here is 60 amp. It's all 60 amp wiring. So if you did want to go down to a battery bank, you could. And there's a couple different options you can do with this. You can actually charge a battery bank and have the wind system switch over to a grid-tied inverter. So let's say, at 10 miles an hour and lower, you want to put juice in the battery bank, okay? And 10 miles an hour and above, you want to go to a grid-tied inverter. Well, you can simply do that by switching these dip switches in here. These dip switches go from 5 to 40 mile an hour in increments of 5 miles an hour. So every one you push up is a 5 mile an hour increment. So right now it's set on 5 miles an hour. If you pull down number 1 and pull up number 2, it'd be 10 miles an hour. If you pull down number 2 and pull up number 3, it'd be 15 miles an hour. So what we do is, this is how the switching occurs. You have a relay here, and if you notice, there's a black wire under the relay. That would be going to your, if you were using a 250 watt grid tied inverter, let's say 10 to 30 volts, and a 500 watt grid tied inverter, or 1000 at 22 to 60, what you would do is you would hook your 250 to this relay, which is the positive side, and then hook the negative over here to the negative bar. Okay, and then when the wind gets up to that speed, it will shut that inverter off, because on this part, you will have a 22 to 60 positive lead connected to this bus bar here. Okay, so the 22 to 60 is always online. It's always sitting here ready to go. However, this relay shuts off at a certain wind speed. So if I spin this wind cups, you'll see these relays shut off. And there is a delay, see? And then turn back on when the wind drops. So right now you're on 22 to 60 for high wind. And when the wind speed drops, you'll be back into your lower inverter for 10 to 30 volt, because there's not that much, you're not getting a lot of RPM. So you want to stay in a lower wind zone with a lower wattage inverter. As soon as the wind gets up again above 10 miles or 5 miles an hour, as this one's set at, we would really be setting it on 10. That's the optimal setting, is 10 miles an hour. All right, now your turbine's running at a higher RPM and lower amps. Now the wind stopped again and it's back down. So the beauty of it is that the turbine voltage, or I'm sorry, the system switching is not based on the turbine voltage, which a lot of guys, you're frying stuff and all that. It's based on wind speed, and all your power comes from wind speed. So if the wind's higher, you're in a higher inverter and you're more efficient that way because you're running higher voltage and lower amperage. If you're in a lower wind speed, then you're down in the lower voltage area, which means that you can still convert power instead of waiting for 9, 10 mile an hour winds when you only have a 22 to 60 volt inverter. So there's a couple ways we can go with this. We also have a voltage switch we can put in here that reads from 0 to 100 volts. So we can switch that way, but I'm not a big fan of depending on the turbine voltage because stuff can fry. And I tried to make this as not only rigid, but less electronics the better. So, I have this here for your meters, and I have this here for the control, and that's it for electronics. Everything else is pretty much mechanical. So there's not a lot of stuff in here to blow up. And you can add a DC lighting arrestor. You could add an AC lighting arrestor if you want. Your DC lighting arrestor can simply just get hooked to your DC terminals here. You have them over there, and there's another system over here. So each system is basically the same. It has 2 DC breakers, two rectifiers, 2 bus bars. It's all set up for 2 turbines, and then ultimately the 2 turbines will come back to the grid and feed in. So for this kilowatt meter, you could plug a 6-way into it and plug all your grid-tied inverters in. All right, and come up with one system on the AC side for an overall watt production. What else do I got to cover here? The board. The board itself is bolted in, so you can pop this whole board off and work on it. You do have to disconnect a few things. Some of the AC stuff you have to disconnect, and the DC breakers you have to disconnect. But other than that, there's 4 nuts on this board, and you pop them nuts off, and this whole board comes off. It's as simple as that. And you can put a lot of juice through this thing. Like I said, it's rated up to 60 amps. Whatever you want to do with it. I could pack different relays in here. We could use it for a dump system. We could actually have another relay system in here switch where if the wind is 35 miles an hour, we can send this to a dump load and protect the turbine that way and not depend on this dump load here. There's many, many ways to wire this system up. It can go battery and grid tie at the same time. There's a lot of different things to do, but I love it because it's compact and it's in a nice hard metal box, and I put hinges on it so the door swings all the way open 90 degrees. It's very accessible. There's a hard cover on this here, so you can't put your fingers in there. And I've tested these relays. I've had very good luck with them. And because these relays are switching at such a low wind speed, we don't have to worry about huge arcing and blowing these things out. Okay, so that's pretty much it. I hope you like the system. We're selling these now. This one here is going out for $800. They take me a while to build. I have to get some parts are from China. Can't get them in the U.S. The relays are from China. The meters are from China. And I believe that's it, unless the rectifiers are from China too. But, you can get that stuff on eBay. But I try to keep it as American as possible and try to keep the cost down as possible and think of all the logical things that would help you get your turbine system up and running. So instead of having all this hodgepodge on the wall, you have it all right here. It's all right in this box here. Now, the only thing I didn't include in this was a brake. That's something if you want to put in here, you can. You can break it on the AC side. You can break it on the DC side. Whatever you want to do. That I didn't put in here. I'm not sure how many guys want to put the brakes on, but all you really have to do is just clip a couple clamps onto these inputs here and short it out, and you're done. Okay, you're not going to be putting a brake on in 90-mile-an-hour winds or 30-mile-an-hour winds. You're not going to put your brake on anyway. Otherwise, you'll rip the blades off the turbine. So if you simply want to use a brake to shut the system down, all you have to do is put a jumper wire between these three, or just put a jumper wire over here, or even here, and just short these out. And that'll lock the turbine down from spinning. All right, it won't hurt the system. But you certainly don't want to ever put a brake on it in the middle of a wind event. That's the reason why I didn't incorporate one in here. I'm afraid that somebody's going to get a little antsy one time and hit that brake in 30-mile-an-hour winds, and they're going to destroy the system. So it's better you just have a jumper wire with a clamp on it, and just leave it in the box here. And when you want to work on the turbine, just clamp your wires together, and you'll be good. And that'll lock the turbine down. You can work on it, then release it. Or if there's a wind event coming that's 50, 60 miles an hour, you can just put your little clamp wires on here, short it out, and then when it's done, just pop them off. Okay? So again, this is our box. It's a 16 by 16 box. It is for grid tie inverters, the Chinese type, which all you guys know. You've seen these guys before. And what I'd like to do is I'm going to put the camera down a minute, and I'm just going to set it here. I'm actually out at my outdoor bar doing this video. It's very nice and night out. It's actually beautiful out. And what I'm going to do is I'm going to hook the meters up, shut the door, and we'll spin this wind blue PMA. Now, this wind blue PMA, this thing will overvolt the system in a heartbeat. And that's why I'm not a big fan of using these car PMAs, because they just want to produce high voltage. They don't want to produce many amps. So, in saying that, we'll run it for a little bit, and I'll show you how it works and how quick these meters are, if I can do it holding the drill and everything else. So, there's the meters there. Everything's on. And it says off just because we shut the system off. But we're not going to worry about this one because it's not hooked up. The only PMA it's hooked up rectifier is this guy here. So let's see. Let's see what we can do. Let me put this over here for a minute. Just for a second. Just hang on, guys. Sorry about this. I'm all fingers. All right. So let's get the drill in there. All right. So we have the drill. Drill's in there. And let's see what happens to the meters here. I'm trying to stay under the voltage. And we go to the watt meter. See it overvolted. Well, I'm not a big fan of these. But I'll give you an idea of how quick this meter reads. It's pretty damn good. And again, I'm just spinning it here, my drill. This side of the road is doing its thing. And this is a 10 to 30 grid tied inverter. But you'd also check the efficiency too. We got about 10 watts coming in there. And we'll revolve it. Keeps overvolting. So not a good PMA to be running with this. Okay? And that's the system. And again, your wind speed's up here. I don't know if you heard that click, but that means that they just switched. The inverters would have been switching by now. And you can see the voltage dropping. You can see the capacitor from the grid tied inverter starting to unload. And there's a little bit of residual voltage on here, but that'll go away. Once you have all your inverters hooked up and your ground's hooked up, I don't have a ground hooked up to it. I just have this little makeshift extension cord here to show you guys. Once you get your grounds hooked up and everything, your residual voltage will go away. All right, but the meters are nice and quick, man. And again, we can, I can switch them up, man. I can put power on the top, volts on the bottom, whatever I want to do. Great little meters. All right, but again, you do need 12 volts. A battery bank is key for this. However, you can run a transformer to do it. The only thing is, if the grid goes down and you don't have a transformer, you know, you're going to lose your meters. That's all. And you're going to lose the control system of the wind meter. This won't read either. So it's good to have a little battery bank. Throw a little, you know, 20-watt solar panel in there, 30-watt solar panel in there, and have at it. All right, guys. I hope you enjoyed the video. I know it was long, but there was a lot to say about this box. I think it's some breaking through technology here to help everybody with these guys, because I know they've been a nightmare for everybody, and I'm blowing them up. But one of the key things I want you to notice is using this type of PMA is not that great. I mean, you know, I'm spinning with my fingers, and yes, it is making voltage and all that nonsense, but it's too high of a voltage for these systems, and I think you guys should realize that by now. If you don't, the proof is right here that it just keeps overvolting, so you're never going to get the power out of it, and that's a lot of problem. All right, this is Larry from leamyelectric. If you have any questions, you know, ask me. I'd be happy to answer them for you. And again, we make these systems. They're custom made to your needs. So if you have one turbine and it's 1,000-watt, 24-volt, we can definitely make it work. I found that the best turbine to use with this that I found is an HYE 24-volt. It seems that everything across the board works well, all the way up to 1,000 watts. We have a couple in the field that we tested, and I have a customer that did it and sent me a video, and it's working flawlessly. So I'm not trying to sell them, but I'm telling you that they're the ones that I've tested, and I've had no luck with these type here. Okay? All right, guys. Thanks a lot, and please ask me some questions if you need to. Take care.